Okay, so let's look at example 1 here, where we want to locate the zeros of a function. So we are going to determine the consecutive integer values of x between which each real zero is located. So what that means is if there's a zero located between 0 and 1, we want to write that down. We want to know that somewhere between 0 and 1, between those consecutive integers of 0 and 1, we find a output of 0 on our graph. And whether there are any other consecutive values, like is there one between 1 and 2 or between 2 and 3? Which values of x, consecutive whole number integers, will we find are zeros? That's what we're trying to figure out based off our table here. Okay, so our graph is x to the fourth minus 2x cubed minus x squared plus 1. So step 1 is to make a table. So the table's kind of filled out for us. Because f of x is a fourth degree polynomial, it will have as many as blank real zeros or none at all. So the answer here is based off the degree of that polynomial. Since we have x to the fourth, it will have as many as 4 real zeros or none at all. Okay, so it will not necessarily have 4, but it will not have 5, it will not have 6, it will not have more than 4. It could have 3, 2, 1, or 0. It might not have any real number roots or solutions to the equation where this function equals 0. That may never happen, but at most it will happen 4 times. We'll have 4 zeros in there. Okay, using the location principle, we should identify there are zeros between x equals 0 and x equals 1. So we're saying between these two locations here, right? Because we go from a positive number to a negative number. And there should be one between 2 and 3. Because we go from, once again, a negative number to a positive number. Okay, so whenever we switch positive to negative or negative to positive, we imagine there must be a 0 in between. Okay, so let's sketch that graph. Let's put all the points on here that fit on the graph. It looks like that's going to be from -1 to 2. Everything in between there. This 19 on here is not going to fit onto my graph. My graph only has, 5 spots to do. So we're just going to do the other ones. We're going to say when x is -1, we're up at 3. When x is 0, we're at 1. At 1, we are at -1. At 2, we are at -3. And those are the ones we can put on the graph. Okay. So where did we say that there were zeros? Well, there's a 0 between 2 and 3. So we're going to cross over the graph between 2 and 3, which means we must be going up here. We are going to cross over the 0 between 0 and 1. So right there, we're going to cross over. Okay. And therefore, we are probably going to have a graph that looks something like this. Okay, it'll be roughly like that. Okay, and now we want to check. So use technology to check the location of the zeros. Input the function into a graphing calculator and confirm that the function crosses the x-axis between x is 0 and 1, and between x is 2 and 3. Okay, so I've already kind of got that ready on Desmos. So when we put this equation into Desmos, you are not seeing my Desmos tab. Let me see if I can fix that. One moment. Okay, here we go. Thank you for waiting. Okay, so if I put that into Desmos, I do indeed see those points that I expected. I see a 0 that is between that is between, what are the axes of my graph here? Let me zoom in a little better. A 0 that's between 0 and 1, and 1 that's between 2 and 3. So that first value is 0.72. and the second value is at x equals 2.3. So let's check if that matches the book. 0.72 and 2.3. There we go.